Okay, I'm going to start now, Christoph.
Okay.
It's okay. I changed to Spanish to welcome all the attendants. Bueno, buenos días, bienvenidos. Muchas gracias por asistir a nuestra cuarta webinar ya. Una serie de webinars que empezamos hace cosa de un par de meses aproximadamente y donde pretendemos plantear temas de interés para la industria farma, cosmética e industrias afines. Yo soy Gerard Carrasco, director de la empresa Comac, que conjuntamente con PRODITEC son las empresas organizadoras de esta sesión. El título del evento de hoy es la reducción o reducir el impacto de la no calidad con la industria 4.0, donde el señor Riboulet empezará realizando un recorrido por la historia del control de la calidad, repasando personajes históricos de este concepto, desde finales del 19 hasta nuestros días. Asimismo, repasaremos los conceptos asociados a la calidad como Lean Management y Lean Quality System, entre muchos otros. Y finalmente, Christoph nos hablará de ejemplos prácticos de cómo realizar acciones de control con las tecnologías actuales. Bien, les informo que vamos a mantener los micros y cámaras cerrados. Sin embargo, en cualquier momento durante el evento pueden transmitir sus preguntas a través del chat, que va a permanecer siempre abierto. Bien, antes de entrar en el contenido del mismo, les expongo un breve resumen del programa. Por un lado, vamos a realizar una breve introducción de las empresas organizadoras, en este caso Comac y PRODITEC, unos 7 minutos aproximadamente. Posteriormente presentaremos al señor Christoph Riboulet, nuestro speaker para hoy. Acto seguido le pasaremos la palabra a Christoph para que realice la presentación, que va a durar alrededor de unos 35 o 40 minutos. Y finalmente abriremos el turno para responder a las preguntas del chat, que estimamos unos 10 minutos. Si hubiera preguntas que por falta de tiempo quedarán por responder, no se preocupen, mandaremos todas las respuestas en los emails. Una cosa más. Les informo que la presentación de Christoph se va a realizar en inglés. Pues bien, siguiendo con el guión, paso a presentar ahora la empresa Comac. Por un lado, ahí está. Bien. Comac es una empresa fundada en el año 2005 como proveedora de soluciones industriales para los sectores farma, dietética, veterinaria y cosmética. Las áreas que trabaja o que abarca son el proceso para sólidos, incluyendo granulación, compresión, recubrimiento, cápsulas, liofilizados, envasado tanto de sólidos como líquidos, y estos últimos tanto en ambiente estéril como no estéril, packaging primario y secundario, donde incluimos líneas blister, formatos de líneas blister de cualquier fabricante, y envasado tanto en contenedores de plástico como cristal y estuchado. Luego tenemos la división de control de calidad, donde tenemos los equipos para la inspección de comprimidos y cápsulas, donde tenemos ubicado a PRODITEC, pero también la inspección de viales, inyectables y bolsas. Finalmente tenemos una última división que llamamos procesos auxiliares, donde tenemos 3 divisiones, una que serían las cabinas de limpieza, que usamos para limpiar formatos, material de laboratorio, depósitos y bines, siempre en ambiente GMP. La impresión de los materiales de packaging, aluminio, estuches y etiquetas, y líneas completas para la decoración y metalización de envases. Bien, paso ahora a presentar a PRODITEC. Bien, PRODITEC es un fabricante francés de equipos de inspección automáticos para comprimidos y cápsulas, pero que paralelamente también trabaja para la industria de la moneda. Está presente en más de 40 países y tiene una base de equipos suministrados de más de 350 unidades. PRODITEC ayuda a más de 100 empresas farmacéuticas a mejorar la calidad de sus productos y está siempre motivada por la innovación y la mejora continua. La empresa actualmente ofrece 4 modelos básicos de inspección. Por un lado tenemos la línea VisitUp con 2 modelos, 1L y el 2L, perdón. Ambos modelos están pensados para poder realizar la inspección total de cualquier posible defecto en tiempos reducidos y son equipos offline. La siguiente serie de equipos, estamos hablando de el InspectCaps, que es el modelo para la inspección de cápsulas, y el Teonis, que es el modelo para la inspección en línea, y para realizar las mediciones de concentración de API. Pues bien, llegados hasta aquí, si les parece, paso a presentarles ahora a nuestro speaker de hoy, el señor Christophe. Christophe Ribolet, CEO y presidente de PRODITEC, es máster en Ciencias de Computación, Tecnología de Visión, Inteligencia Artificial y Robótica, así como MBA. Lleva más de 10 años de experiencia en el Lean Management y Christophe ha sabido conjugar la organización con el desarrollo de las capacidades de las personas. De este modo, ha sido como PRODITEC ha fabricado soluciones más innovadoras y una industria plenamente sostenible. Pues bien, sin más que añadir por mi parte, les dejo en muy buenas manos. Espero que el tema de hoy les guste y les aporte valor. Y por mi parte, volveré al final de la presentación de Christophe para moderar el turno de preguntas y respuestas y para la despedida final. Bien, muchas gracias y hasta dentro de un rato. Christophe, it's
Yes.
Your turn. You can share your document.
I can share my screen.
Yes.
Can you see it?
Yes, perfectly.
Okay, good. Let me arrange that. Okay. So thank you, Gérard, for this introduction, and thank you for allowing me to talk about quality today, and especially the impact of non-quality. Every time I think about quality, I think about loss. It's a little bit strange, but when you think about it, people think that quality, it's normal to have a good quality product. It's a due. It's not an expectation. It's normal. So when people talk about quality, it's generally when they don't have the quality, and it's a loss every time there is a quality impact, because of course you know loss in the financial of the company, but it's also a loss of course for the customer. It's a loss for the employee also. Usually people they are proud of doing their work with the best quality possible. But also it's a loss for the society as a whole, because when you think about loss of quality, you think about waste, and waste is one of the major contributor right now to the environmental problems. So it's a very challenging topic, and it's going to stay for long. So it was interesting for me to prepare this webinar, because I try to take a step back, and I would try to share with you the history as I see it, and as I could find on the different documentation. Okay. So let's take a step back and see where the quality is coming from. In 1940, Walter Shewhart was the first to talk about quality differently. He talked about quality as improving the process instead of quality as just looking at the final product and removing the improper one. So he introduced the mathematics and statistics in the quality, and he's the first who has introduced the SPC, statistical process control, for monitoring the process. And then we have Deming after let's say between 50 and 90. Deming used the work previously done to think about what is quality, and he discovered that quality is not only math. Of course, it's not enough. The quality is more a system of thoughts, and he discovered that it's management system. So top management has to be directly responsible for quality improvement. So he was the first also to use the terms of PDCA, like continuous improvement, TQM, total quality management, and also he was the one who introduced the tools like acceptance quality level for acceptance sampling. So he was using tools, but also adding a layer of total management to be able to satisfy the customer in terms of quality. Around the same time, we have Juran, and Juran also went a little bit farther, and he added the human dimension to quality management, understanding that the quality is becoming from the human relation problems, and he emphasized the resistance to change as a root cause of quality issues. but also he used a lot of tools, tools that we know to today, like Pareto tools. He used the Duran, what we call the Duran trilogy, the way of improving. So he described a way of improving quality, meaning quality planning, quality control, and quality improvement. And he was also the one who introduced a cost quality model, saying that there is an optimal level of quality. That means if you try to improve quality further, you're going to increase the cost associated. So he said, okay, there is one optimal quality level, which is below 100%. That was his work at that time. So a lot of tools, people start understanding that there is a management system that is necessary to improve the quality. But at that time, after that, okay, there was a different view in the world in terms of implementation. So, for example, TQM enjoyed widespread attention during the late 80s and early 90s, but it was, especially in Europe and in the US, overshadowed by ISO 9000 and Six Sigma. So it was really a fork in terms of how people and countries view the way they were going to improve the quality. And the view is can be summarized like this: in US, in Europe, the quality tools are made to comply to regulation and norms. In Japan, the management system has to be supported by quality tools. And it's interesting to see that Deming and Duran went to Japan and teach the Japanese what they have discovered, and the Japanese listen differently from European and US people. So they are well recognized now in Japan to be the first to really explain what is a management system and how it can be implemented. So if we look at implementation in terms of US and Europe, we have these two different implementation. That's Six Sigma, and Six Sigma is really a statistical tool to control the variability of the processes, and it's using statistics plus or minus 3 sigma to define what is good and what is bad. Okay, and it's kind of more complex tools because it requires some kind of experts in the company to be able to help people and the company to improve. We can see, for example, DMAIC roadmap, problem solving project in 30 steps. That means you need to have the proper training to be able to implement this. So it was very popular, especially for GE company, who implement this with a lot of success in terms of improving, but also with some limitation. If we look at the other, let's say the management system, ISO 9000, it's interesting to look at the roots of this system. It has been set in place only for contract management. That means contracting between the buyer and the supplier. So how the contract was made. So it was huge improvement to write about quality inside this contract. And also we have people who studied the effect of this, and they found that it maximized the shareholder value. So it's a financial and contractual view of the quality. And that's from that, everyone has started to use ISO 9000, thinking it's the right management system for implementing quality. But if we look at the root, it comes from contractual and financial. Interesting. If we have a look to Japan, it's a very different approach that they have made. And if we look at the root, it's really the TPS, Toyota Production System, which is an integrated socio-technical system. It's a management philosophy and practice. So the tools cannot be removed from the management system. It's a complete system. And it's not new. It has been started let's say, in the 50s by Taishi Ono and Eiji Toyoda first. And if we look at Lean, what is Lean? Lean is really the study and practice of TPS. Lean is not something that has been invented. It's just Womack and Jones, for example, they have studied, they wrote the book, The Machine That Changed the World, trying to understand how Toyota people implemented the quality system described by Duran and Deming, actually. And it's still under study, I would say. There is no end of this study. It's still evolving all the time because it's a natural evolving system. So if we take this story and if we put in contrast the situation in the pharma industry, I've searched for different measures here. So it's US numbers only. And the first curve is the national drug shortages per year. So we don't see clearly improvements. That was my point here. It's still a challenge. So it can be explained by the world is moving, and it seems that the way the quality is implemented is still creating problems. And we see that 62% of this shortage are due to quality issues. If we look at recall product, the same, we don't clearly see an improvement right now. So it's still a lot of recall products. If we look at the FDA and how the FDA defines quality today, the code of federal regulation, so it's not old, it's April 1, 2020, and the quality is defined as the compliance of the sampling plan. That's and defective, it's non-compliance as a sampling plan. So it's a very minimum, I would say minimum description on what the quality must be implemented, how the quality must be implemented. And from my experience, what we see widely in the industry is that quality is still relying on human to do the work of checking individual, let's say tablets or capsules or vials in this case. And that comes from that brings us to the cost of non-quality, and the cost of non-quality is I think it's largely underestimated. So it can be estimated over 10% of sales, which is very, very large, but sometimes it can be more than 20% of the sales. And of course, we see the visible costs like delay to market, waste, but there are a lot of costs that we don't see. So it was time to redefine the destination with different initiatives. And I found it interesting to also summarize this type of initiatives. If I look at Europe, especially, there was an initiative started by the German government in 2011, which is the Industry 4.0, and it promotes innovation and technology in the industry, meaning computerization, digitalization of the process to be able to monitor the process better. And very new, it starts from 2021. It's the Industry 5.0 already. We have not finished with the 4.0, but we have started with the 5.0. And why is that? Because they saw that, once again, the story is there, the tools are not enough. You also need the people. So, and also you have to take care of the environment. So the Industry 5.0 is describing a more sustainable, human-centric and resilient European industry. If we look at the pharma, in 2004, there was a new regulation, pharmaceutical CGMPs for the 21st century, describing a new approach for controlling the process and describing also new tools. So it's quality by design. So it's a structured process for designing and launching new products, but it's not new. It was outlined by Duran in 1992. And also PAT, which is the tool part of this process. So how you use technology also to be able to design, analyze, and control pharmaceutical manufacturing processes through measurements of critical parameters. And after that, I would say side by side, there is the management system, once again, which is the OPEX, well known in the industry, trying to bring a new view of what will be the right management system to be able to implement quality and everything related. So we, once again, come back to TQM, for example, associated with TPM, total productive maintenance, and also just in time, coming from the lean philosophy. Okay. Also, a different way of looking at quality is try to understand existing concepts. So if we look back, Chingo, he has promoted a different view of quality. He has promoted a zero defect philosophy through source inspection. So different from, if you remember, Duran said there is an optimum point where if you start to increase quality, you start to increase associated costs, and it's not worth doing that. Shingo is seeing things totally differently, saying you must go to zero defects. And you do that by starting at the source and trying to catch every defect at the source so that there is no propagation of the defect. So of course, he's using some tools like Pokayoke, which is a tool to prevent errors. And he's just saying if you can prevent mistakes, you can reach zero defect at the end. So it's a very interesting view of quality. Another very interesting view is Taguchi, and especially the Taguchi loss function is trying to redefine how we see good and bad. If you look at on the scheme on the left corner, you see it's a standard tolerance where you have to produce inside the tolerance. What is inside is good, what is outside is bad. Okay. But Taguchi said, no, you have a loss, and the loss starts from the point where you are not on the target. So even though you are not outside of the tolerances, you start generating loss. And this is a very interesting view because you can start using this loss measurement to be able to improve, even though you are not outside of the tolerances. So it's also a very different view of how you can tackle quality issues. Also, I can relate to my own experience. It's been now more than 10 years that we have started to implement Lean in our company. And now we understand that Lean is just not a set of tools. Of course, there are tools, but it's really a continuous and dynamic learning management systems. And it's based really on two pillars, it's just-in-time and Jidoka. Just-in-time, it's the management of time, really time management, and the tools are pull system and Kanban. And Jidoka is the quality part associated with the time part. And the quality part just means stop at defects. So we retrieve the same concept as, for example, Shingo. We try to catch defects as early as possible. So it's related to source detection, and andon is how you stop the line, for example, stop and try to get some help to be able to start again as soon as possible. And this is the process of learning. So that means programs are made visible in the company and are solved by people on the field. They are not solved by specialists with very complicated tools. It's a very simple tool that can be used by everyone. And doing that, so this is our experience, that you can really improve people capabilities. And at the end, that's people who can really decrease lead times and increase quality for, of course, increasing customer satisfaction and decreasing waste at the end. So that's just some pictures of PRODITEC assembly cells. And we see that most of the tools are already implemented. It's never-ending story. It's always evolving. We can always improve how we see the tools and how we can use the tools, of course. So we have Kanban, we have andon, we have Obeyas also to talk about issues. We have production control and logistic to use the Kanban system, and also Kaizen. And this is done with and for the people. It's not just a separate initiative. So also I have the chance to work with Michael Ballet, which is my sensei, and is the famous author of the Lean strategy, which is interesting. If you're interested in Lean, I recommend this book. So now if we take all this context and we use this context to go into the case of automatic solid dose inspection, that's our products. So this is a tablet inspection machine, of course, to detect defects. And it's a lot of technology inside. We have cameras, we have a lot of computer, electronics, mechanics, a lot of technology, but the real important thing is how this technology can create value for the customer. That's a real question. And if we look finally at how this can create value, there are several examples. It really depends on where the customer is in terms of quality mindsets. I've described 4 different levels. The first one is people who are using sampling and manual inspection when they have issues. The second level is they want to automate this manual inspection, replace the manual inspection by automating to save the batch, actually. The level 3 is to have a preventive action and they want to inspect 100% of their product. And the level 4 is to automate the source inspection. So I can describe and start with the level 2 when customers they have a batch saving problem. So that means they run the production, the batch, and they accept the AQL is failing. So they can use the machine to be able to process this batch and come back to a normal situation as soon as possible. So it's offline, usually it's small volumes, and it requires a lot of flexibility and accuracy on the machine. So if we look at the non-quality impact and the value we can bring, the value in terms of quality is pretty low, I would say, because there is no improvement. The quality is wrong, it's already done. So what do? So you can just react to the problem. But this is still bringing some value to the business because you can speed up rework, you protect the production schedule. You don't have to make the production again. You protect delivery time of your customer, and of course you prevent waste. That means you don't have to throw away the batch which is defective. So typical customers are I would say smaller companies or generic companies with a very high product mix and low visibility, and which are cost sensitive. They cannot afford to throw a batch away. And also some big labs, they usually have this type of tools in terms of just in case, I would say. It's a safety quality tool. If we move a little bit further, we have some companies, a lot of companies now, they want to automate and do a 100% inspection. This can be done because of the speed of the machine. It's totally automatic, reliable, repeatable. So the idea is really to have a final check after, for example, the press or after the coating or after the filling for the capsule, for example. So it's really inline machines with usually large volume. Output is very important and accuracy is also important. So it brings a little more value in terms of quality because at least it protects the customer. If you send some batch to the customer only with sample, you cannot prevent that there is no problem in the batch. Of course, you have your quality level, but if you are the customer who receives the problem, you have 100% problem. It's not the quality is not a statistics. If you are the one who is unlucky, you are 100% unlucky. You have the problem. So at least this can protect the customer. Of course, it can ensure to pass the AQL and prevent rework. So that's the first advantage of that. So typical customers come from especially Japan. Japan has defined this type of level of quality. 100% of Japanese products are inspected. Every company that wants to export to Japan has to do 100% check. New product, critical product, it's also very important to ensure the proper launch of this product. Also, we have seen that some big labs, they want to outsource the product, and to be able to be sure that there is 100% quality, they require this type of check. We also have the example of generic and CMOs, especially in India, for example. When India started to produce a lot of generic, India has equipped with this type of machine. For example, PRODITEC has more than 90 machines in India right now. Also, nutraceutical is a good example of that. So if we move a little bit higher in terms of level, that's the higher level. It's how you automate the source inspection. So we come back to the also Shingo, and also we come back to Taguchi, because automating source inspection, meaning checking for data, getting some data, even though it's not defect data. So you try to have as more data as possible to be able to see if there will be a defect in the future or not. So it's really a process monitoring loop when you start to monitor your process, get data, And with the camera, we can get some 2D data. With the laser, we can get 3D on surface, and we can use, for example, NIR to get the physical and chemical properties of the tablet or the capsule. And of course, you have to analyze this data, and that's where you can bring the people in, because people will understand with the data what will be the next improvement phase of the process. So of course, this is the more value we can bring with this type of system. It improves production processes. It can engage people in quality also. That's a major point. And typical customer are today the big labs with the OPEX initiative and QBD and PAT initiatives. And it relates very well with the continuous manufacturing. So quality is really a never-ending journey. We see that it comes from old concepts, I would say, but right now everyone is sharing the common goal. Everyone agrees that we need to create a culture of excellence, reduce waste, and improve processes. But the difficult part is really the implementation. It's really the key part of quality concepts are not new, but how you implement them is really the difficult part. So tools and philosophy also is with people is very important to mix. So that's where technology can help. Really, or we can use technology to move toward a more integrated quality management system. Like a source inspection that we have seen can also reconcile compliance and continuous improvements. And it can align QBD, PAT, and OPEX programs and initiatives. And of course, people stay at the heart of the quality journey. We need to lead them in the right direction and provide them with the best possible tools for improvement. That's really the very, very important part. So I will finish by sharing this picture I took in Japan at the Nagoya Museum, and it's under the Toyota Museum. Making things means making people. I leave you on that to reflect. Thank you very much for your attention. Gerard, you want me to share your screen?
Yes, can you hear me now? Okay.
Yes.
Thank you very much, Christophe. It's been very, very interesting. We have a question from the chat from Jaume. I'll read it literally. In the last years, we have detected an increasing number of requests in the market for hybrid machines. That is machines that are enabled to inspect tablets and capsules, both products. What do you think of the current technology being able to process both products with the potentiality of different sizes, shapes, etc.?
Yeah. Okay. So that's interesting. Usually, people who are asking this in the first level, I would say they try to switch from manual inspection to automated inspection. So they want to remove manual inspection. So yes, when they want to remove manual inspection, they look at their manual inspection process, and manual inspection is very easy. You put people, you put a belt, and you put product. And usually when they have this system, they have tablets and capsules. So in the past, I would say that our aim was more concentrated on level 3 and 4, I would say. So level 3 and 4, people use machine and they are dedicating the machine for some type of product. They don't need a hybrid machine. But for the first level, the need is growing, and that means a lot more and more people now want to switch from manual to automatic inspection without changing their quality and management system. Mm-hmm. So that's the first step. So what we've seen is that some people started to do only with tablets, and now they want to do that tablet and capsule. So it's the challenge is now to provide them with I would say the cheapest way to enter to this process to be able to start automating. And of course, it makes sense to be able to make the tablets and capsules And that's something we are going to do, because now we see that more and more people are entering this technology, actually. So it's an entry point, and it makes sense if you want to just replace what is the existing. It makes sense to do that. But I will say that the step after is really to have dedicated machines to be able to do the proper job for the product.
Okay, thank you. And he's mentioning also, what about the soft gel capsules? Because I know this is a totally different technology for inspection. Why is it so difficult to use the same machines?
The main point for this type of machine is really to understand the challenge of handling the product at high speed. We're talking about, for example, for tablets, we're talking about 300,000 tablets per hour, and now we are releasing a machine this year to go up to 600,000 tablets per hour. So the way the machine handles the tablets, it must be very accurate, very stable, because of course you need to get the proper data on these tablets. So the difficulty with the soft gel is the different shapes, all the different shapes there are on the soft gel, and also soft gel, they also need a lot of output. So for example, there are some machines to be able to inspect a soft gel at 1 million per hour. That's a requirement, but at 1 million per hour, they don't see the proper defects. So it's always a compromise on what type of data quality you need to get from the product to be able to also do something with it, and the ability to handle this product and feed the product inside the machine, and of course the costs associated with this. So there is the problem is well documented in the soft gel industry. The main issue they have in the soft gel industry is the leaking. So when the soft gel is leaking, that's where they have to stop the process to be able to stop to wait for let's say 24 hours to see if there are leakers or not. And doing this with a machine at high speed, it's not easy, but it's a topic. It's a good topic.
Okay, I have one question. Well, you mentioned that with Theonis, it's possible to measure the chemical composition or detect the mass distribution and the AP components, right?
Yes.
So this is going to be a requirement, do you think, from the administration, public administrations, or this is something
requirement? I don't know. In terms of requirement, we see that the FDA is very slow to adopt and to put some more requirements, and they want to be able to have less requirements. But the point is that if we want to be successful in the source monitoring, we need to have the proper data, and of course. To be able to do that, we are working on different sensors. So I've talked about traditional sensors like camera or laser with the cameras, but new sensors are NIR, of course, Raman sensors, and also terahertz also sensors. And the technological challenge is really the high speed of this type of sensors. Everything is existing on the market, but sometimes very low speed, very high price. So now I would say the way is really to decrease the price of this system and increase the ability to do more. I would say more product per hour.
Okay, very good. Thank you very much, Christophe. There aren't more questions, so yes, we can finish now today this webinar. I'm switching to Spanish to say goodbye.
Okay.
Bueno, pues muchas gracias a todo el mundo. Gracias por vuestra atención, por asistir a este webinar, por vuestro tiempo. Simplemente añadir que si quieren consultar más eventos como el de hoy, pueden visitar nuestra web en www.coma-casol.com, en la pestaña de recursos, sección webinars, donde también podrán consultar las sesiones ya una vez realizadas. Esta misma sesión estará disponible en unos días, tanto lo que es la presentación como la grabación de la misma. Y también les informamos de este email, el info@comac-casol.com, por si quieren mandarnos sugerencias, seguir haciendo preguntas o información general que quieran consultar. Pues nada más que añadir. Muchas gracias a todos y que tengan una buena jornada. Hasta pronto.
Bye bye.
Bye bye, Christoph. Thank you.
Thank you.